Morning. Welcome everyone, and thank you for joining us today. My name is Tiana, and I'm a part of a telecom company in Belgrade, Serbia. I will be a moderator of today's webinar, the link between clean energy and circular economy. And before we start, I just want to inform you about technical instructions. So this webinar will be recorded for everyone who couldn't join us today, since we received a lot of inquiries because of the people who are on vacation, but they still want to hear what we're going to talk about today. So if you have any questions during the webinar that you want to address to our speakers, please feel free to type them in a chat box and I will bring them in a Q&A session. Now, before we start with our first speaker, I would like to say a few words about Circular Economy Balkan Beacons project. So Circular Economy Balkan Beacons project is an international project supported by AIT Climate Kick, and it has a consortium of 6 countries, Bulgaria, Germany, Greece, Romania, Bosnia and Herzegovina, and Serbia. And what this Circular Economy Balkan Beacons project is creating actually is a physical space, a so-called beacon that enables circular economy implementation throughout collaborative, integrated, cross-national services summarized in 4 pillars, abbreviated as a WIRE. And what we represent are values and visions that we're sharing between consortia. Also, we are sharing information regarding needs, policies, demands, facts, and figures. Also resources, mainly in form of knowledge and human resources, but finance and innovation also. And there we have experience and expertise in different circular economy domains. What this project is doing actually is connecting Balkan countries and push circularity business foundation throughout innovation. And our vision is to create socio-economic system that produce profitable, safe, fair, clean, and resilient circular market in Balkans. And the goal of this project is to build an ecosystem for circular climate-related innovations that catalyze system transition in sequences from experiments throughout collaboration to implementation. And I need to say that this project is very specific because one such cross-national ecosystem currently doesn't exist in Balkan, yet it's seen as necessary to reduce a risk of negative influence of new market requirements and to raise potential of regional circular niche solutions. This project also provides expertise in circular economy Balkan countries to support fast knowledge and practice distribution on cutting-edge circular solutions, supports circular state-of-art niche adoption, best practice and metric-driven policy making for low-carbon systemic circular economy catalyzation, guiding regional supply chains throughout circular transition, and attracts investors and founders for novel circular solution. When I tell you about this short story about Circular Economy Balkan Beacons project, I would like to announce our first speaker, Mr. Azrudin Hushika. He's a professor and doctor on the Faculty of Mechanical Engineering, University of Sarajevo. Mr. Hushika works on development of studies and strategies in the field of energy and the environment. And as an independent expert, he was engaged by the UN Development Program in the preparation of first, second, and third national climate change reports, in charge of developing and analyzing GHG reduction scenarios, as well as development in the Bosnian low carbon development strategy. He's the president of the working group for the implementation of their energy efficiency model in Sarajevo, and also a leading expert on air quality, climate change, and energy within the drafting of the environmental strategy and action plan for Bosnia, Federation of Bosnia, until 2030. So, Mr. Azrudin, if you can hear us, you have a word.
Thank you, Tiana, for the introduction. I hope that you hear me well.
Yes.
Good morning, everybody, and thank you for invitation. It's my pleasure to be with you and to have opportunity to present the presentation on the linkages between clean energy and circular economy within your project. So let me share my screen with you, my presentation. I hope that you see my screen, my presentation.
Yes, perfect.
So just to put on the slideshow. Yes, so as you said in the introduction, the topic is a link between clean energy and circular economy. And I'm sure that for all of you, it's quite clear that clean energy is a quite important element of the circular economy as a whole, since production of energy is quite resource intensive activities, and especially within the activities focused on climate change fighting, clean energy is a quite important element of circular economy. I will try in the next maybe 20 minutes, I will try not more, to share with you just some of my thoughts on the linkages between clean energy and circular economy, and what are the opportunities in this context, especially for the countries of the West Balkan, since we as Western Balkan countries are members of energy communities, and in the, at least in the energy sector, we can say that we are part of EU. So I'm sure that you are aware that practically all regulations are more or less the same in the Western Balkan countries in the field of energy as it is in European Union countries. So starting from climate change fighting, clean energy is a basement for efficient mitigation of climate change. And these days we are surviving one of the manifestation of climate changes. These days in the region we have so strong heat waves. On this picture we can see the illustration of the process and different layers of fighting against climate changes. And during some trainings and seminars when we organize it as a physical meetings, then I ask participants what they see and what is their impression when they see such picture. And then people divided in two groups. One group is pessimists, and they see on the picture house, that they see that there is no strong organization and straight activities on the picture. However, the second group, they are optimists, and they say that they see many opportunities on this picture, opportunities in different sectors of the society. So not only in engineering fields, but also in the health protection, then research on the basement. So the conclusion is that climate change fighting offers a lot of opportunities for creation of the new jobs. And clean energy is one important part of that, especially on one side of the roof. It is mitigation. Of course, in parallel, we have to hardly work also on adaptation. However, when we discuss about the clean energy, then we concentrate more on the mitigation, and there are some side effects of mitigation measures also on the adaptation. So in order to in efficient way to respond to the climate change, obviously that we have to change the paradigm of economical development. And here we see the comparison between linear and circular economy in the context of energy in general. So it's not only clean energy, but including also energy from fossil fuels. On that picture, as you can see, the author of the picture of the comparison, existing economy called normal economy. I wouldn't agree. Actually, I don't agree at all, because normal economy, what we have today is not real normal economy. And on the right side, we have illustration of circular economy. And now we can compare the differences. In the linear economy, we have production of energy and consequence of the energy generation, some emissions and some waste. The approach in the circular economy is that we reduce emission, then we reduce waste, and we use energy according to its level. Sorry, somebody is unmuted. So in the industry, we use energy according to its level, as on the bottom of the right picture, you can see that we reduce emissions and use waste heat from the industry, which is one of the quite important element of circular economy. So we have to change from the existing business models, which is illustrated in this picture. This is a newspaper article, old, almost 20 years, but more or less the situation is the same, at least in the Western Balkan countries. For those who doesn't speak our, let's say, regional language, just to explain that newspaper said that due to the warm winter, the company which deals with supply of the natural gas in Sarajevo, they recorded financial loss because they supplied less natural gas because winter was warm, which is, I am sure you would agree, totally unlogical or ridiculous. So this is a good illustration, because we can see that the existing business models is based on the interest of one side, and one side can make a profit only in the case when another side record financial loss. So for the inhabitants, the warm winter is good. However, for the companies, it's not good. It's a financial loss. In order to switch from such kind of business models to circular economy, when the interest will be synergetic from both sides, we have to change the system from the basement. So we need radical changes in order to create a new business models which are illustrated on that picture. On this picture, we can see the energy system with clean energy, or economy with which is climate neutral, so without net emissions of greenhouse gases. We can see a lot of installations for production of renewable energy, and a lot of installation for energy storages. All these plants are connected with IT technologies. It means that such kind of concept of energy system create a lot of jobs, which is in comparison with the jobs in the traditional energy sector on the higher level of quality. So it is a high level of high level quality jobs, because we are talking about the sophisticated technologies with coming from the offices in the urban areas, unlike the jobs we have in the traditional sectors like coal miners and similar. So more jobs and more higher quality of these jobs is a key message. In order to make transition from the existing models to the modern, to the models which is based on the clean energy, we have to pass through several transition elements. First element is transition from centralized energy system to decentralized energy system. It means that in the future we will have a lot of small installations instead of a few big ones. In parallel, transition means transition from carbon intensive energy, and all energy generated from fossil fuels are carbon intensive energy, unlike in a clean energy system when we produce energy from carbon-free energy, which is all renewables and waste heat from different industrial processes. It will enable that ownership will also change. In the recent situation, we have ownership of energy system mainly in the big companies, and in the majority cases, these are state-owned companies. And the citizens are not actively involved in energy system, they are just consumers. In the clean energy system, due to the decentralization, due to the construction of the many small plants, many small installations, citizens also can be owners. And then we approach to the prosumer system. So citizens, they will be not only consumers, but also producers of energy. And the last but not least element of energy transition is transition from the model where we subsidizing energy consumption, which still we have a lot of examples in the region. There are plenty of ways and sometimes it is hidden subsidies for energy consumption, mainly for fossil fuels. Then we have to switch to subsidies for energy efficiency. And fortunately, we have also a lot of examples where different governments on the different levels subsidizing energy efficiency instead of energy consumption. But still, as I highlighted, still we have some subsidies for energy consumption, which we have to cut as soon as possible. Energy system of climate neutral economy is based on 4 elements. The first one is renewable energy sources, and it is the most, I would say, important element and the most promising element from different aspects, not only in energy mix, but also in providing of green jobs. The second element is energy net positive buildings. It means that buildings generate more energy than they consume, not in every moment, but when we balance energy on the annual level, then the situation is that buildings will generate more energy than they consume. Very important element is energy storages, because integration of renewables requires a lot of ways of energy storages. As we know, the wind and solar, they are intermittent energy sources. And in order to balance demand and supply side, we need a lot of energy storages. Additional element which will enable more integration of renewables are smart grids and e-mobility. So some examples of clean energy and new paradigm, new approach to the development of energy system is e-mobility, electrical cars, and some concept can be based on the multifunctional use of electrical cars. And then we improve a lot of sustainability of the whole system when we use one product, one good for different purposes. Here is illustration of using of electrical cars for movement from point A to point B, and at the same time we can use electrical cars for balancing of electrical grid. When we don't need movement by electrical cars, then we can rent to operator of distribution system in order to balance demand and supply side of electrical grid. It is a situation when we leave the car on some big parking spaces where we have thousands of electrical cars, then it is significant capacities for balancing between demand and supply side, especially when we have a lot of wind and solar energy on the grid. At the same time, we can improve resource efficiency by production of energy on the place where we need this energy. Example is own production of electricity for industry, for households also. Unfortunately, in majority of countries in Western Balkan, we don't have net metering yet. However, as far as I know, there are some efforts in this context to introduce net metering, which will enable installation of photovoltaics on the roof of the households in a cost-effective way. Also, a big space or opportunity for circular economy, and maybe the best example in the clean energy area is production and use of biogas plants. All countries in the region, they have subsidies for such kind of plants through feed-in tariffs, which is quite attractive, especially in some of the countries. However, there are some other obstacles for installation of biogas plants. So we don't have in operation a lot of biogas plants as we can, based on the potentials. But what is the point of and connection between biogas plants and circular economy? Because everything around the biogas is in a circular shape, starting from the production of raw materials and ending to the products. And products products are electricity, heat, biofuels, organic fertilizers. So all products we can use in place and for rolling the new cycle of the production. At the same time, we improve energy security, then we support rural development, create green jobs, and providing a new investments. At the same time, we improve the quality of life and quality of environment on the very local level. These are the cycles of different raw materials and elements of the biogas plants. So starting from the agriculture or from some other areas, we can get raw materials not only from agriculture, also from the communal waste and from industrial waste also. So whatever is products of agriculture can go to the biogas plant, and from the biogas plants we have composts and fertilizers, which can then use for the new cycle of the production. At the same time, we generate quite competitive energy, especially heat is quite cheap due to the subsidies for electricity, and then marginal cost of heat is quite acceptable for different activities, like we will see on the next slide. So the biogas we can use in quite different ways and obtain added value for our agricultural production, like using for district heating. However, usually it is an issue, because then we can utilize heat just during the heating season. And even during the heating season, we have quite changeable needs for the heat. So then better way is to use available heat in some processing industry for greenhouse, or for drying of different goods like wood, plants, and etc. If we are not able to invest in the using of heat in different ways, then the option is cleaning of biogas to the quality, to the level of the quality of natural gas, and then we can substitute the natural gas by biogas, and then in this way to get to provide some some effects to the climate change mitigation. In Bosnia and Herzegovina, we have a few such plants, and several of them are in the process of the construction. So I'm sure that in the whole region, it is quite high potential. Also, when we discuss about the linkages between clean energy and circular economy, the interested example is waste to heat as a concept. And this is just illustration of one possibility. There are a lot of examples and possibilities of the concept of waste to heat as a combustion of communal waste, etc. However, I put here illustration of using of the waste heat, which is in the content of the sewage water. Namely, sewage water can have temperature between 12 and 20 degrees of Celsius, depends on the consumers. Especially attractive for such kind of installations are hotels and some public buildings which provide accommodation for people, and there are a lot of consumption of sanitary water. And then by very simple technology, we can use the heat in the sewage water just by installation of the heat exchanger, which provide input energy for heat pumps, which are the baseline source for the heating system, and district cooling also can be supplied from heat pumps. This is not the often case in our region that we use sewage water on that scale. However, there are some examples on the level of some public buildings that such installation installed, and results and experience is quite good. So this was short as possible, and now I am looking forward to your questions. Thank you for your attention, and now we can open discussion. I'm sure that you have some questions, and I just use opportunity to apologize because I'm not sure about how my connection is strong, because I'm not in the office right now, so that's why I switched off my camera. So, question.
Everything is good, don't worry.
Okay.
So I collect a few questions, and the first one would be, what are the benefits of decarbonization for the local community, and what would be the first step on that path? And I also see that somebody leave a similar question: what should be driving force for the energy transition at the local level?
So these are quite good questions, because everything starts from the local level, and clean energy should be considered bottom-up, in bottom-up approach. So when we speak about the local level, in the presentation I started and highlighted the global driving force, which is climate changes. However, mayors on the local levels, they are not so interested, and I think that they even shouldn't be so interested for climate change mitigation on the global scale, even though the local communities, they suffers because of the climate changes, but they should have some other driving forces like better quality of life and better quality of environment. So clean energy is a precondition for clean air. Many cities in the region they are heavily impacted by emissions from the fossil fuels, and during the winter we have unfortunately still every winter catastrophic air quality in the region. So this should be the primary driving force for the local level to to provide to citizens green jobs, as I illustrated in some examples, then to use the local resources, local potentials of energy, and also to mitigate emissions, but not greenhouse gases, but emissions of pollutants on the local level, like sulfur dioxide, NOx, and PMs. So this should be the primary driving force. And second part of your question is related the approach, which is the first step which should be done in this context. The first step is a strategic decision of municipalities or cities or higher level of authorities, whatever. And then based on this strategic decision to identify the particular opportunities. Is it agriculture, or is it some city infrastructure, whatever, and then to focus and to base the future development on these opportunities, and then to work with the local entrepreneurs, which are the most important element of the local development, to get them on board, not just to inform them, that because it doesn't work in this way, but really to get them on board for the circular economy in the context of energy production. Yeah, that's short answer. Of course, the topic is quite wide.
Thank you. In the presentation, you mentioned the really good examples, and what do you think? Why there is no transition if we know that this is a good path? What do you think? What is the main problem?
I wouldn't say that there is no transition. There is transition, but it's quite slow in the comparison what we will want, or in comparison with opportunities. However, for the faster transition, or the transition on the bigger scale, we need the radical restructuring of the whole system, as I highlighted on one slide, the 4 elements of the transition. And one of the very critical element is the changing of ownership. This is a very significant and sensitive issue, because the companies which is owners of the existing systems, they fight to keep the status quo. And then I'm sure that this is one of the biggest barriers in the line of the faster transition. So the existing system, they have a big inertia, and to change anything we need time, and the time is decades, so no years but decades, unfortunately.
Thank you. And from the part of the authorities, do you think that they can make this transition faster?
They can, but we have to provide them the right driving force. As I said, we cannot approach to the mayors of the municipalities asking to do something in order to reduce emission of greenhouse gases, in order to mitigate climate change. But we have to present their real interest and time needed for that, and in parallel to take care about the some groups in the society which can be negatively impacted by transition. Always there are some minority groups from different aspects, disabled people or retired people, whatever, who can be negatively impacted in the transition, and that's why there are local authorities in the often cases, not always, but in often cases, they are a little bit reluctant to the faster transition.
Thank you, Professor. Thank you for this interesting topic and the presentation. Now I would like to announce our second speaker for today, and that is Mr. Christos Stefanatos. I hope that I pronounced it well. He's a project lead in EV Loader. He worked for a major renewable energy investment company and developed VBA and MATLAB scripts for energy production. And he's also founded a Purity Platform, a fintech startup that develops digital solutions to accelerate transition to cleaner energy. So, Christos, can you hear us?
Yes, thank you so much for having me. It's an honor to present alongside great speakers. And if you are ready, I can share my screen and begin my presentation.
Yeah, you can share.
Great. Great. So in today's presentation, I wanted to outline the aspects of electric vehicles and how electric vehicles fit into energy circularity. So starting off very briefly, I wanted to discuss the reasons why we believe that the future is electric, so that the mobility of the future will be based on electric cars. And the main reason for this is that the internal combustion engine that is used by conventional cars, by most cars till now, is a very complex engineering machine. And aside from being way more polluting to the environment, but also from an engineering perspective, it's a very complex machine with a lot of potential maintenance and failures. So when we look into the electric motors, you can see that it's a way simpler engineering construction that requires less maintenance, and it's easier to manufacture in a line of production as soon as this.
Sorry, Christos. We cannot see your screen actually.
Okay.
Can you just reshare it again?
Yes, allow me. Maybe I should only share the presentation. Maybe now it's gonna be better. It's better now?
Yeah, it's better now.
Okay. All right, let me. So just to show the previous slide in case you missed it, this is an internal combustion engine that is way more complex as an engineering feature compared to an electric motor that is used in electric cars that is way simpler from an engineering perspective, way easier to manufacture in a manufacturing line. So this is one very important aspect that we believe that will. Sorry, I was muted.
Yeah, we can hear you.
Okay, so the electric cars have lower maintenance costs and also lower running costs, but they are also facing some challenges that do not allow them to explode and grow exponentially as they should. And the most important issues are mostly in urban areas where drivers do not have their own parking lot and they have to rely on public charging spaces. So this is a very important challenge that also requires the involvement of the local authorities to solve. And the other issue that many electric car drivers that might be among the audience have experienced is that the charging experience when you are away from home, when you're traveling, is not optimal. You usually have to use multiple apps in different locations, and you have to keep way more apps in your phone that you would like just to charge your vehicle in different locations. And here's another reason why we believe electric vehicles will shape the future of e-mobility and will also shape the future of the electric grid. As it was mentioned in the previous presentation before, as the renewable energy percentage among the energy production is growing, the potential for curtailment of renewable energy production is also growing, because we cannot control how strong the wind blows or how long the sun shines for each day. So there are occasions where, when we have a large percentage of renewable energy capacity, that we will not be able to absorb all this renewable energy capacity in the grid, and some of this energy will be essentially wasted. We will need to disconnect solar panels from the grid because we cannot absorb the electricity they will be providing, or apply the brakes on wind turbines because the grid cannot absorb the energy that would come from the strong winds on that day. But at the same time, as we expect this to happen, we also expect the total number of electric vehicles to grow, and they can be a solution for this, because electric vehicles can work as a flexible storage tool. And this can happen through smart charging. So we understand that it's better to use renewable energy over conventional fuels to power all of our activities. And same applies for an electric car. You buy an electric car to be more sustainable, but if you are powering it with fossil fuels, you're still making progress, but it's not the optimal scenario. And the optimal scenario is powering your car via renewable energy sources. And it's even more sustainable when you make sure that you time your charging when you have surplus energy from renewable energy sources. So trying to absorb any excess production that would not be absorbed by the rest of the grid, houses, buildings, industry, to be absorbed in the electric cars. Why is that? Because electric cars have the battery, you can store energy and consume it on the next day when you will have less windy day, less production from renewable energy, and more potential need for fossil fuels. So here's an example. So when you have more available renewable energy capacity than the grid can absorb, the charging cost for the cars will be lower, way lower than a normal day, to incentivize drivers to charge at this specific time interval. And at the same time, on a day that the renewable energy capacity is not sufficient and you need to also insert energy from fossil fuels, the charging cost will be way higher to disincentivize drivers to charge, because if they charge, they will be increasing the need for fossil fuels. And also imagine that if they preferred to charge on the previous day where they could draw energy from renewable energy sources, they decrease the need to charge on the next day, so that they decrease the need for fossil fuels. So it's a double benefit, absorbing excess renewable energy capacity, and on the next day, reducing the need for fossil fuels. And the next step that we believe will take at least 4 more years to see a greater scale, especially in Southeastern Europe, is discharging. So on days that the renewable energy capacity is not sufficient to power the grid, offering the opportunity for electric car drivers to discharge a part of the energy stored in their car, if they are not planning to use it, to power buildings and other demand centers, and avoid using fossil fuels. And of course, to achieve all this, the charging station management apps need to be interconnected with grid operators, energy utilities, in order to be able, on real time, to have a forecast on the capacity of renewable energy that is flowing on the wind, or the demand that is that is present on the grid, and ensure that there are pricing changes and modifications in the charging capacity to ensure that electric vehicle charging works in favor of the grid. And of course, having such functionality on charging apps benefits public agencies, because they can monitor and shift demand according to the conditions on the grid. And also this can provide additional analytics to the public agencies to ensure that the charging locations are evenly spread out and utilized at the correct time intervals. And it also helps charging station owners, because it makes a win-win situation for their users, for the drivers that charge in the charging stations, and also for them, because they have greater occupancy spread out throughout the whole day. And of course, electric drivers can benefit, because if they can charge their car at specific time intervals at way lower cost, this is also beneficial for them and improves their overall experience and cost efficiency. And just closing off, to share some things about what we do here in Greece. We have a charging station management app that is focusing on efficient usage of renewable energy sources. It's mostly used in charging stations managed by hotels here in Greece, and it's spread throughout mainland Greece and on the islands. And as I mentioned before, it informs drivers for opportunities to charge at lower costs when the charging station owner or the grid operator applies such a discount. And we have been moving on with pilots with municipalities, with the municipalities of Athens, the Greek Chamber of Hotels, and we have also been funded by Climate Kick, and we are very grateful for that. I'm sharing some pictures of the locations where they have installed hotels. If you ever come with an electric car to Greece, you should check out our app, because we have great hotels that you can visit. And finally, as a call to action with all my fellow participants, right now we are structuring Horizon EU calls related to grid flexibility, vehicle-to-grid solutions, smart charging, and increasing the uptake of renewable energy sources. With our partners from National Technical University of Athens and Athena Research Center. And if anyone is interested and has ideas or is looking for pilot partners in Southeastern Europe, feel free to contact us and we can discuss further. It would be very interesting. And we also have a running program right now that is focusing on smart charging, an ICT call from Horizon 2020. That is running with National Technical University of Athens and the largest private energy utility here in Greece. That's all from my side. I'm looking forward to your questions, and we can also connect via LinkedIn and all our company's social media. Thank you so much.
Thank you, Christos. I would read a few questions that that are addressed to you. How high do you believe cost reductions should be incentivize drivers to charge when there is surplus from renewable energy sources?
That's a great question. So the cost reductions, imagine you are driving around with your car and you need to charge. You need a strong incentive to delay your charging or go out of your way to charge in a different location. So what we are exploring with our energy utility partners are significant discounts, more than 50% of the charging cost at specific time intervals, of course, because we believe that at lower changes, the drivers might not bother to make that move. Of course, there are many drivers that are very conscious about their decisions, and even with lower cost reductions, they might take the detour. But we believe that for the majority of them, they would require some significant incentive.
Okay, thank you. And you mentioned hotels. So do you think that a large business such as hotels, as you mentioned, can combine renewable energy installations such as solar panels with smart charging?
Absolutely. Smart charging is even more convenient for hotels that have solar panels on their roof, because they do not even need to coordinate with the grid. They are essentially their own microgrid, so they can change their pricing strategy depending on the production that is coming from their rooftop solar panel, and, for example, offer way lower cost to their clients and guests to charge at the time intervals when they have surplus production from the solar panel on the roof, and increase the cost when all the air conditioning is running and all the production from the solar panel is depleted just from the hotel operations.
And can you tell us what will be the total amount of the flexibility that each electric car can add to the grid annually?
Yes, so this is around between 1 megawatt hour and 2 megawatt hours per year for each electric car, assuming that it charges around 20% of its charging sessions on smart time intervals. And just as a sense of scale, these are 10 100 kilowatt solar panel farms operating for 3 hours. So a single electric car can absorb the production of 10 solar panel farms of 100 kilowatts for 3 hours. And imagine that this would be energy potentially that would be wasted, that it would be curtailed, it would not be able to be absorbed by the grid. So it's a significant percentage of energy, and it's a significant reduction in CO2 emissions as well, because if you think about it, this energy, if it wasn't absorbed on this day, it might be absorbed on the next day, but from fossil fuels, because the next day would be cloudy, but the demand would still be there.
Yeah, exactly. Thank you. So I would invite our participant to ask you a few more questions. So if nobody has any question, I would like to thank you, Christos.
Thank you.
Very interesting insight. I would just like to add that this webinar, as I mentioned at the beginning, is recorded, and it will be on our YouTube channel, Circular Economy Beacons. And also, I would like to invite you to follow our social networks, where we will publish the following webinars, calls for trainings, implementation of circular economy in companies and cities. So thank you all. Thank you, Christos, once again.
Thank you.
Thank you to Professor Azrudin. Thank you all for be a part of this webinar. After the webinar, you will receive a feedback form, and you will also download all the presentation from today's webinar. You will be able to download it at the end of the feedback form. So thank you once again, and see you in the next one.